Okay. So now we're getting into power theories, which could very well be the most challenging portion of the course. I've tried to make the problem at least somewhat more humane than they have in the past. So, I mean, I taught this class during my very first semester at USM. And before that, I've been teaching at Stanford. And I knew that I would have to adjust the difficulty level. And I wasn't sure how much to adjust it. And back then, apparently it was not enough. So it was a stressful time for all, which is why I had cupcakes made for the class. So still gonna do that. So I guess sometime after spring break. Okay, so let's see how things go. But
Professor?
yes.
Okay, we can't see what's to the left of the word series. If you could like back the camera up a little bit so we can see the full thing, because we can't really see the full we can't see the full board.
Okay, so
nope, we can only see an R.
That's really weird. Hold on a second. I forgot to spotlight it. I don't know if this will help.
I mean, I can see it just fine.
Okay, that worked. Power series, okay, that worked.
You might have your aspect ratio wrong.
Okay, so before I continue, can y'all see all the way to the right edge of the board?
Yes.
I can't see the end of it. I don't. Okay, how would there be a way to change my screen, or I can see the X?
Okay, let's get more ambitious. Can you see this X?
Yes, that's the very end of it, though.
Okay, I'm gonna draw a line. My right boundary. Okay. That's my domain. Okay. But what makes this course this material challenging is that it's necessary to look for patterns. What pattern recognition involves. And then to determine what's the approach to take to a certain problem. Now, we'll see lots of examples, and hopefully that'll give you the help that you need. But this is why it's important to keep questions coming, whether inside or outside of class, to make sure you can get through the problem. So I've gotten a very small number of questions asked through the Lumen service, and I think no one's asked me a question over email at all, which is just weird because in years past I used to be flooded with them, but nowadays people just choose not to ask questions at all. So you're great. So so what is power series? It is a series that has this form. We have some coefficient Cn, and you always have in the nth term x minus some number x naught raised to the nth power. So that is what makes it a power series as opposed to an ordinary series. So here we have some coefficients, and then the number x naught, which often will be 0, but not necessarily, that is called the center of the power series. So I'll be using that term frequently. Okay. So what sets a power series apart from an ordinary series is that the terms of a series, which consists of this entire expression here, depends on the value of x. So whether the series converges or not is going to depend on X. So that's a question we're going to look at today. So for which X does the power series converge? And for that, we're going to use the techniques for determining convergence or divergence that we've already seen, ratio test, alternating series test, things like that. So that's the focus for today. Later on, we'll be looking at if you're given a function of y equals f of x, can you write down a power series for it? Or vice versa, if you're given the power series, what function does it represent? And those kind of problems are ones that can be a bit of a pain, but I'll give you some approaches that you can use to work out those kind of problems. Okay. So when it comes to figuring out for which X the power series converges, here's some possibilities. So scenario one is power series converges for all X. So these are 3 scenarios that we can have. So it converges everywhere. That does happen. I'll show you an example of that shortly. Second possibility is the series diverges everywhere except when X is equal to the center. When X is equal to X naught. Okay. So whatever the center is. In fact, power series always converges at its center.
The X number is just the original X value, right?
It's this value right here.
Yeah, but that would be the original X value, or can that change?
Okay. And if this is some fixed value for a given series, and then X can be anything.
Okay.
Yeah. So if you substitute X equal X naught in here, all terms go away. Except what? All the terms are, if I set X equal to X naught, all the terms are 0 with what exception? Yes, because if I set X equal to X naught, I'm going to have 0 to the n. Well, that's always 0 except when n equals 0, because anything to the 0 is 1. So then the series is just equal to the first coefficient, C naught. So you always have it converging at that point. The question is, does it converge anywhere else? And then the final possibility is the series converges when X is sufficiently close to the center. So X minus X naught is less, in absolute value is less than some number R. And it diverges if X minus X naught in absolute value is greater than R. I've not said anything about equals to R yet. We'll come to that later. That's a hit or miss thing. The number R in this case is called the radius of convergence. So basically, radius of convergence could be infinity in this case, effectively 0 in this case, or it could be some fixed number. So So for the homework assignment for this portion of power series, vast majority of the problems will be about determining the radius of convergence and what happens at the endpoints of this interval where x minus x naught is equal to r. Does it converge or diverge there? Okay. So to determine which of these scenarios applies to a given series, the best thing to do, approaching a boundary here, ratio test is the best thing to use. Because that will help you get to radius of convergence, at least. Okay. Okay, I'm gonna look at some examples here. So suppose our power series is x to the n over n factorial. So Cn in this case is 1 over n factorial. Let's go to 0 very rapidly. The center x naught in this case is 0. So if I plug a ratio test,
Wait, that's 1 over what? Cn of 1 over what?
over
C
n factorial.
equals. Oh, okay, that's exclamation mark. Okay.
So ratio test, we take the limit as n goes to infinity of the n plus first term divided by the nth term in absolute value. So x to the n plus 1 over n plus 1 factorial divided by x to the n over n factorial. And in this case, what I like to do is write out the n plus first term and then take the nth term and flip the fraction. So then we can see, and take like expressions and see what you can cancel out. So for instance, we have x to the n plus 1 over x to the n. Well, that's going to simplify to x. And then here we have n factorial divided by n plus 1 factorial. Yes, I was about to ask, how does that simplify? Yes. So because n factorial is 1, 2, 3, 4 multiplied all the way up to n. Here we're multiplying 1, 2, 3 up to n plus 1. So everything cancels except this n plus 1 down here. So now we're going to take the limit of this as n goes to infinity. But keep in mind, x is some fixed value. We could pick x to be anything we want, but since x remains fixed, what's this limit going to be?
0.
It's going to 0 because the denominator just keeps getting larger and larger. Eventually, we'll overtake x, no matter how big x is. So when the ratio test gives you 0, I mentioned before that if the limit is less than 1, it converges, and that qualifies. So it converges no matter what x is. So it converges for all x. Another way of putting it is a radius of convergence is infinity. He's come up with another class. So you would recognize what series this is.
Oh, wait, Professor?
Yeah.
How did you simplify it to x over n plus 1?
Subtract the exponents to give you x.
Okay.
And then n plus one factorial is equal to n factorial times n plus one, just by the definition of factorial. So so that would cancel out, cause the n factorial to cancel out. And then,
So the n factorial, so it's just n plus, so the factorial cancels out, and so it's just n plus 1.
just
And,
n plus one by itself, yes.
Okay.
Power series for e to the x, the exponential function. So we'll be seeing more of that later on. Any questions about this one? All right, here's number one. Our terms are n, x to the n. So the center is again 0. Another way of writing it would be n to the n, x to the n. So this portion right here, n to the n, is the n. Okay, but that kind of coefficient is going to grow pretty rapidly. So if I form a ratio test, limits as n goes to infinity of n plus 1 to the n plus 1, x to the n plus 1 over n to the n, x to the n. Okay. Now, to help simplify this, I'm going to take this n plus 1 to the n plus 1 and write it as n plus 1, and then I have n plus 1 to the n. So just by adding the exponents. And that, okay. So taking one factor of n plus 1 and writing it off to the side here. That way I can combine those two and see what I can simplify. And then x to the n plus 1 over x to the n, that's just x. So then I have plus 1, and then I have n plus 1 over n, which is the same as 1 plus 1 over n, all raised to the nth power times x. Now, as n is going to infinity, this x remains fixed. That part is still growing. We don't know what is happening with this. Actually, does anyone know offhand what that converges to? It comes up in problems relating to compounding of interest. But yes, it converges to E. Now, for those of you who I'm sure y converges to E. All right, so that's for this part here. This converges to E.
Wait, Professor, how did you get to the n plus 1 times n plus 1 to the power of n over nx? How did you get to that?
This?
Yes.
Okay. I have n plus 1 factors of n plus 1. So I just separate write one of them separately. That's going to give me n factors left.
Oh, okay, okay. That then you had Okay, then that's simplified to the x. Okay, to the okay. Okay, I
Okay.
got it.
Now, the limit as n goes to infinity of 1 plus 1 over n to the n, what we could do with that is instead work on this, take the log of that, natural log of that, try to get that limit. And then once, if you can figure this one out, then you can exponentiate the result. Now, using the properties of natural log, I can take this n and pull it down. Still nowhere with this. So now what I'm going to do is write n as 1 over n. Then I have ln 1 plus 1 over n over here. Okay. So as n goes to infinity, if you look at top and bottom individually, that's going to go to 0. And then we have, as n goes to infinity, this becomes natural log of 1, which is also 0. So this is a 0 over 0 indeterminate form. So we can use what? L'Hopital's rule.
Everyone.
All right, so now take L'Hopital's rule. So derivative of the bottom, that's going to be minus 1 over n squared. And then for the top, we're going to have 1 over 1 plus 1 over n times the derivative of what's inside the log. And that is going to be minus 1 over n squared. So minus 1 over n squared will cancel. And we are left with the limits of 1 over 1 plus 1 over n. But for this, as n goes to infinity, you can see that this is going to be 1. So because this goes to 1, the original expression converges to e to the 1, which is e.
A lot of moving parts there.
All right. Like I said, like in problems involving a continuous compounding of interest, this kind of expression comes up where you might have like 1 plus r over n, where r is interest rate, and n is the number of times compounded per year. So as the number of times compounded per year goes to infinity, that's continuous compounding, you get an exponential growth, and that's why you save early for retirement. Okay. That's why this part goes to E. I probably should not have spent that much time on that. Right. So this limit, so that's a constant E, converting to a constant. X is a fixed constant. So we have a limit as n goes to infinity of n plus 1 EX, but that's infinity. So this series never converges, except at the center, which is 0. So it diverges. Except at the center, x equals 0. So this is the opposite from previous example. So I want to show you the extreme cases where a series converges everywhere or basically nowhere.
Can you hold on a second? Just trying to write everything down.
Okay. There's also a question from online. Why not use the root test. Actually, yes, that would have worked well for the original series, since the whole thing is raised to the nth power. So, then we wouldn't have had a chance to do any of this, so. Okay, yeah, so root test, the limit is n, if you're taking the limit that goes to infinity of this whole thing raised to the 1 over n, which is just nx, and that would also go to infinity.
Professor, just at the far right, does that say equals e to the power of 1 minus e?
E to the 1 equals e.
Okay, okay, got it.
I feel like I'm missing something. So what's the R? Or like, if it,
Radius of convergence, you mean?
yeah,
0. Yeah, if it diverges everywhere except in the center, then has a radius of convergence of 0.
Is the R like a value that's like in between 2 points, or is it the actual point itself?
Okay. Radius is a distance
Mhm.
from the origin. So as long as you're within that distance of, not the origin, the center, within which the series converges. It's gonna become clear in the other examples we're gonna do, which will actually have a ordinary number as a radius of convergence. Yeah, so what we've seen so far, extreme cases where R is infinity, converges everywhere, first example, and then here where it converges nowhere, we say R is 0.
so if it's if the limit is infinity, is R is always 0?
Yes.
Right?
Yeah. Yeah, 'cause that means that no matter what x is, as long as it's not the center, it's diverging. Yeah, I guess again, so television, you think, okay, any examples, use ratio test, which majority of the time is the best thing to use. And I guess when I wrote these notes 13 years ago, did things use a root test for this particular one. It's not often useful, but this is one of those times. So good catch there to point that out. All right. Now another example. Here, x to the n over n instead of x to the n over n factorial. So we try the ratio test again. So here we have x to the n plus 1 over n plus 1 divided by x to the n over n. But I'm going to write that as a flipped fraction. Just cut to the chase there. And what happens is, so this simplifies to absolute value of x times absolute value of n plus 1 over n. So what happens? So what does this limit turn out to be as n goes to infinity? Oh, sorry. My brain shut off for a moment there. Okay, now, yes, you'll still be the same. What happens to this as n goes to infinity?
It'll be infinity over infinity.
But using various techniques for working out limits like that. One, because you can use L'Hopital's rule on this. Yeah, so this part goes to 1. And what's left is the absolute value of x. Now, but the thing is, ratio test, we need a limit that's a number, and then so if the number's less than 1, it converges. If it's greater than 1, it diverges. So what this tells us is the series converges if absolute value of x is strictly less than 1. And it diverges if absolute value of x is greater than 1. So another way of putting it is r is 1. So if you conclude that absolute value of x minus the center converges, if you determine the series converges if absolute value of x minus the center is less than some value, in this case 1, that is the radius. So that's what you're looking for. Convergence under that circumstance. That's the next thing. So this covers everything except for when absolute value of x is equal to 1. So in that case, you have two endpoints to consider. In this case, x equal to plus or minus 1. So you need to substitute those values into the series. Because when absolute value of x is equal to 1, that limit is equal to 1, the ratio test is inconclusive. So ratio test has told you all it can. So now you substitute these values in here into the series and see what kind of series you get, and does it converge or diverge using other tests. So we have two cases to consider. If I just substitute x equal plus 1, we get, oh, whoops, that should be starting from n equal 1, 0. Okay. So in this case, we just get 1 over n. What happens to that? That diverges. Yeah, it's harmonic series. And in the other case, x equal to minus 1. So we go ahead and plug that in for x. So you have minus 1 to the n over n. And what happens in that series? It converges, and by what test? It is an alternating series where the terms are going to 0. Okay. So what we found is, as long as absolute value of x is less than 1, or if x is equal to minus 1, that's where it converges and nowhere else. So this takes me to what is called the interval of convergence. So the interval convergence is x is greater than or equal to minus 1 and strictly less than 1. So that's one way to write it. The other way to write it is if I put a square bracket on as a left delimiter, because we know it converges when x equals to minus 1, and we put a closing right parenthesis because 1 plus 1 is not included in the interval of convergence. So that's really what we're looking for in a problem for determining the convergence of a power series. Really, the final answer is not just the radius of convergence, but the interval of convergence. That tells us how it behaves at the endpoints of the interval.
Professor?
Yes.
Okay, just what does it say at the very bottom right with the is that n equals 1 and then negative 1 parentheses to the power of n?
Yes.
Okay, it converges. What does that say beneath it?
Alternating series.
Okay, thank you.
That's how we know it converges.
Well, then why is it negative 1 in the parentheses? Oh, okay, when x is negative 1 for that.
Equal minus 1 up here.
Okay, gotcha.
And if you see enough examples, you'll find that when it comes to the endpoints, anything can happen. It could converge at both endpoints, diverge at both endpoints, converge at one but not the other, like in this case. So you have to be on your toes about that. So a lot of homework problems are about first getting a radius of convergence, but then you have to examine both endpoints. So now I have more examples of that. One to infinity x minus 8 n over n times minus 3 to the n. Okay. So for this one, because we don't have the entire expression raised to get power, just most of it, this ratio comes candidate again. We have the limits and those infinity. So let's write this out with n replaced by n plus 1. And then I'll write it again. I'll write this exact expression, only a fraction flipped. Okay. And then you can group similar expressions, see what you can simplify. So I'll take the it's n over n plus 1. Then we have x minus 8 to the n plus 1 over x minus 8 to the n. Then we have minus 3 to the n, minus 3 to the n plus 1. When I was undergrad, I had a professor who, for first few classes, wrote on the board, and then the rest of the semester he switched to writing an overhead projector because his arm was wearing out at the board. And I'm starting to feel that, understand how it felt. Okay. So when we simplify, I'll leave that n over n plus 1 there. How's the rest of this simplify?
X minus 8 over
Yeah, x minus 8 over minus 3. Okay, so what happens to this is n goes to infinity. What happens to this fraction? It goes to 1. So all that's left is absolute value, x minus 8 over 3. And we want this to be less than 1 for convergence. So what we have right now, we have a condition for convergence, but we need to write it in such a way that we have absolute value of x minus the center by itself is less than some value. So we need to rearrange this. So if absolute value of x minus 8 is less than 3. So that, the 3 is your r. That's your radius of convergence. So be sure to get it. So once you figure out what your limit is, you write that limit less than 1, and then you rearrange it so that you have absolute value of x minus the center is less than something. That something is the radius.
It should come to 511.
Well, now we need to look at the endpoints. Okay, so,
I'm trying to figure out why you would move them.
oh, sorry, let's see if you're getting ahead. I was making sure that
Why are we moving the 3 over?
To get R.
But it's in the absolute value though, so couldn't we also move over the 8, the -8?
Well, what the meaning of radius of convergence is, it can, that the series converges when X minus the center, which is 8, is
Okay,
less than something. Yeah, so you need a condition.
you need to get X, I wasn't thinking about that.
Okay, yeah. A form, absolute value of X minus X naught is less than something.
Hmm.
Which is the R. Okay. But it starts from this 1 here is because of how the ratio test works. You start with that and then you work.
So 1 is like an assumed
Um,
1.
it's a consequence of the fact that by the ratio test, the series converges if the limit is less than 1. I'm sorry, you had a question over here? I'm sorry, you started to say something about the endpoints.
Yeah.
Yeah, so, but I want to make sure that everything prior to that was handled. So what was your question about that, please?
And I want to so the endpoints come in at 511, is it correct?
Yes, yes.
So my radius would be 3.
The radius is 3. Yeah. Yeah, but, okay, so that's the radius. Okay, so we know that the series converges when absolute value of X minus 8 is less than 3. We know it diverges when it's greater than 3. Now we need to consider absolute value of X minus 8 equals 3. So that means X is equal to 5 and X is equal to 11. The points that are 3, values that are 3 away from 8. Actually, let's write out the full thing here. So X minus 8 equals 3, or the negative of that, minus X minus 8 equals 3. So this one gives you X equals 11. This one, you solve for X and you guess 5. Okay. All right. So then what do? You substitute both X values into the original series. Let's start with X equals 5. So up top, you're going to get 5 minus 8 to the n, so minus 3 to the n over n minus 3 to the n. But what does this simplify to? 1 over n. The minus 3 to the n's cancel, and we know what this does. It diverges at X equals 5. Okay, what's going to happen when we substitute X equals 11? How's that going to go differently? Because now you're going to have 11 minus 8 all to the nth power, so that's 3 to the n up top. We still have n times minus 3 to the n down below. So at 3 to the n over minus 3 to the n, that's going to be minus 1 to the n over n. But as we saw from a previous example, that converges. So our conclusion is that the interval of convergence we have 5 and 11, and because 5 is not included, it diverges there. We put a parenthesis. 11 is included, so we put a square bracket. Another way of putting it, X is strictly greater than 5, less than or equal to 11. So I'm mistaken in notes. I had minus 5 for some reason. Whoops.
How do we change the initial equation
But where exactly?
for x equals?
Oh, okay, all I did was I just substituted x equal 11 there,
Okay,
and that gave me this, and then I just simplified.
okay, so
Other question?
Hold on just a second. Hold on. Why does x go to 11? Why does that one converge?
Because we, after it's simplified to this, we saw this exact same series, another example, this is an alternating series. Where the terms are going to 0, therefore converges.
So it's converges because it's an alternating series.
Yes,
Okay.
this sort of thing that often happens, not always, but often, where you end up with alternating series at one endpoint and not an alternating series at the other endpoint. And then it just depends on what your denominator is. Like if your denominator is n, then this is, we get what happened here, where it converges at one endpoint, not the other. If this had been n squared, it would have converged at both endpoints. Because the P series test, because 1 over n squared converges. So that's sort of another thing that can happen. Any other questions about this one? Nx all to the n power over n cubed. This time it's center is 0. So we try ratio test again. At some point you get sick of it. All right, so we have 10x all to the n plus 1 over n plus 1 cubed times n cubed over 10x to the n. I'll just group things. Group similar expressions together. Okay, and anyone tell me what this limit turns out to be?
Yeah, I can say 1.
Well, that part is 1,
Yeah.
but Yeah.
Times 10 to
Yeah.
10.
so this simplifies to 10x. This fraction is going to go to 1. So you end up with absolute value of 10x. And so when you have powers of n like this, that kind of fraction is always going to go to 1. So that happens pretty much all the time. It's when you have other things like exponential functions or factorials when you get something different. Right, so we get absolute value of 10x. By the ratio test, we need this to be less than 1 for convergence. But you want to write this as absolute value of x minus the center is less than something. So what am I going to get for my radius of convergence? Like 1/10. So that is your R, your radius of convergence. Okay. So now we need to consider absolute value of x equals 1/10. So x is equal to 1/10 or minus 1/10. We need to substitute those into a series and see what we get. X is equal to minus 1/10. I get 10 times minus 1/10, all raised to the n power over n cubed. So what does this simplify to?
The 10n or negative 10n over n cubed.
Yeah.
Yeah, negative one, I'm sorry.
Minus 1 to the nth power over n cubed, and what does that do? That converges. And there are different ways to see that it converges. Actually, it converges absolutely. If you take the absolute value of all the terms, then by p-series test, it converges. Okay. Then we do x equal plus 1/10. The only thing that's going to be different is we're not going to have this minus here. So we end up with just 1 over n cubed, but that also converges. That's a p-series sum of 1 over n to the p, where p is greater than 1. So the interval of convergence, use all square brackets here. So minus 1/10 to 1/10, both endpoints included. Questions about this one? One more. This one is x minus 7, the n over 7 to the n. Yeah. Now for this one, the entire term is something raised to the power. So you can use the root test. And you can use root over ratio, but this one will be quicker. So we have limits as n goes to infinity, x minus 7 to the n over 7 to the n, all raised to the 1 over n power. Oh, and this should be absolute value. So then all of the exponents cancel out. And we're left with just what was being raised to the nth power, an absolute value of x minus 7 over 7. And we need that to be less than 1. So.
Professor?
Yes.
So I just going back. It says converges. What series after that?
P series.
On the right side. P. Wait, what series?
P series.
Okay. Thank you.
So root test works just like a ratio test, and then you get some limits. If limit is less than 1, it converges. But we need to write this such a way that the if absolute value of x minus the center is less than something. So what would that be? How we rearrange this? Yeah, absolute value of x minus 7 is less than 7. So that's the 7 is the radius of convergence.
Wait, can you explain it again?
Okay, so we get this by root test, and then we need to be written in the form absolute value is x minus something, so we want to have only this on the left side. So then, so we rearrange to get it in that form, and then what's on the right side will be our R. And similarly, if absolute value of x minus 7 is greater than 7, it will diverge.
So if it were -7,
Down here,
yeah,
if we were taking the absolute value, it becomes 7.
oh, yeah.
So like before, we have to consider the endpoints. Absolute value of x minus 7 is equal to 7. So x is equal to 0 or 14. So we're going to substitute those values into the original series. So starting with x equals 0. So we'll have -7 to the n over 7 to the n. Now we get -1 to the n. What happens to that series? It diverges. The terms don't even go to 0. What's going to happen differently if I set x equal to 14? We're going to get 1 to the n or 1. If we have 7 to the n up top, we also have 7 to the n down below. So that also diverges. So you end up having, you think of it as a geometric series where the ratio little r is plus or minus 1, so it's going to diverge in either case. So we've seen 3 examples with 3 different conclusions. In the first one, the series converge at one endpoint, but not the other. The previous example, it converged at both endpoints. Here it converges at neither of them. Just to show you that any of these possibilities can happen. By the way, these last 3 examples I did, I took them directly from the homework, just the numbers would be different. So I have an idea of what you're in for. Yes, Lacey, I figure that helps you. So but there's several more problems like them. Yes.
Do you grade what we get on the pretest, or do you give us point? Do you just go back through and set the points to gold?
Oh, well, it doesn't count toward the grade.
Okay.
So that's just for your information. Okay. We have just a little over 15 minutes. So if plans have any questions on these examples or on any homework problems, since next one we'll do in a couple days. Yeah. March 8th. Yeah, the review is on March 6th.
Would we get docked, can someone include it in write every time, the limit to into infinite,
Oh,
but as we're working it out?
you mean like literally writing this right here?
Yeah.
No. And I know you're in a rush in that situation, so, as long as I can follow what you're doing, and I certainly am accustomed to lack of precision from students following what they do. Also, as long as you convince me that you're not simply guessing.
So you get partial credit?
I do give partial credit. Yeah. And I'm probably more generous with partial credit than most of my colleagues who some of them have seen it. It's pretty harsh. So, because what I do is have, like, how much knowledge do you show me? Do you show me Even if you don't get the right answer in the end, did you show some knowledge of material in the course before you got the question, then I'm gonna give you credit for that. Think probably, so what I'll be doing over the Mardi Gras break next week is pre-recording the classes that will occur during the end of February, beginning of March, when I'll be away, but also getting the practice midterm ready. Make sure you have like a couple weeks or so to look at that.
Thank God. There's just a lot of series and things to remember. Like I just wanted something yeah, that I can look at and remember them.
I will be posting one of that, something like that, too. But any story about it. Well, like I said, but it depends on what happens during the review. I can certainly give an overview, but I also want to be able to have time for any questions if someone has about the practice. Um, you have questions about anything? Test, homework? All right, I'll do it then.